now we are enabled to look at this data and start drawing inferences from it, start getting a sense of things. So one simple thing we could do, I suppose, is we could count the number of participants who are above the line versus below the line. So participants below the line are going to have a larger women leader reaction time or response time than on the median, a larger median women leader response time than men leader response time. So I guess we can see we have 1, 2, maybe 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 out of our 24 participants were at least a little bit below the line. We noticed that this one was quite a bit below the line. So that's interesting to note both the count and also note any participants who were a fair bit different from other participants. And then, let's see, we have 1, 2, 3, 4, possibly 5 participants who were above the line, and maybe 1 or 2 participants who were right on the line. So we can we can begin making inferences even just having that information. We can say that the majority of participants had a median response time that was longer for women leader than it was for men leader. We can say, and we can look over here, and it's a little harder to see because some of the data points are on top of each other, but we can get a little bit of a sense that there are more participants who made a greater proportion of errors to women leader than men leader than there are participants who made a greater proportion of errors to men leader than women leader. So we can see 1, 2, 3, maybe there's 2 here, 1, 2, 3, 4, 5 maybe. There are a few folks on the line, 1, 2, 3, 4, 5, 6, 7, 8. Looks like there might be a data point behind there, 9 or something. But again, there's a fair bit of overlap here. So there's maybe some things we're missing. But again, we can get a sense that there are more people down here than up here, and we can start drawing inferences. So that sort of visual intuition is the most important thing that this graphing exercise is aiming for. Many times when statistics is taught, one is taught how to calculate a single number and to think about that single number, and it might be a summary number across all participants, and one doesn't necessarily gain a rich visual intuitive grasp of each individual participant and what's happening for each participant. So that is very important to getting a sense of what's happening. And for some of the same reasons we talked about before. If we had one participant who was way, on this graph, way over here somewhere, and we were just looking at the means, that might drag the women leader mean way over here somewhere. But that might not be telling us about the typical participant. That might be telling us really only about one participant, and if we just computed the mean across all participants, we might get a very skewed sense of what was going on. Okay, so that said, now that we've looked at the data, let's compute two things. Let's compute the mean women leader and men leader score, or the mean median women leader response time and the mean median men leader response time, if that makes sense. So each one of these data points is the median response time for a given individual, and we can compute either the mean of all of those, or we can compute the median of all of those. Note that the median will be less influenced by one or two very atypical participants, which is the strength of looking at medians. Okay, so let's move this graph down and move this graph down. And let's see, if we were to copy and paste these things somewhere else, their references would get mixed up. So we're going to cut those, and we're going to paste them over here. Let's see, where's paste? There's paste. Okay, remember those are our axes. No, those are the coordinates, beginning and ending coordinates of the line that we've drawn, the 45-degree line. So we want to make sure those stay intact. And let's compute the mean, which Excel calls the average, of the median response times. Okay, there's our mean of the median response times. For the women leader condition, there's the same thing for the men leader condition. And we can see just visually here, actually let's make it a little easier to see by reducing the number of points after the decimal point, because we're working in milliseconds already here, and that's precise enough. So you can see that there's a larger number here for women leader than there is for men leader. And we can do the same thing for response times. If we drag this all the way across, we can get the average mean, or the mean errors. And note that since we've taken away all the decimal points, we lose all of the real information there. We need to make that a little more precise, and we do that with those buttons up there. Okay, so we can see that the mean, the average person has about 10% errors in women leader and has about 6% errors in men leader. So again, there's a difference there. And we can plot those differences on the graph. So again, when we want to plot a new thing, we right-click or control-click, we select data, we add something new, and then we tell Excel what we want for the x values and the y values. So let's see, for the x value here, we want the women leader score. Where's women leader? There's women leader. Women leader. And for the y value, we want men leader. We're just doing 1 point here. Before we wanted lots of points. Here we just want that single point. So we just click on one cell. Okay, and look that Excel has smartly given us a new type of symbol for this new plot that we're doing. So it's nice and easy to see that there is the mean from right there. And it even highlights where things are coming from if you click on the data point. Now, does this make visual sense to us? Does it look like horizontally here we're about at the average? Yeah, I think we could probably convince ourselves yes. And do we see that this looks like we're in the vertical, about at the vertical mean as well for the men leader condition? Yes, and is men leader condition a little less than 1,000 milliseconds or 1 second? Yep, it's a little less. And are we a little more in the women leader condition? Yes, okay. So everything is making sense. And we can do the same for the error data. So click on a data point, select data, add new data, and our x value should be women leader, and our y value should be men leader. And there we are. We can, again, see the difference that we noted in the numbers. So, okay, we have gained a good visual intuition of the data. We have plotted a summary statistic across all participants on both of our graphs. We've noted where that is. There's one thing left to do, which is to say, is this dot right here meaningfully different from the line here, which would represent no difference? Is it meaningfully different than the dot here? Clearly, there is some point at which there could be such a tiny difference between this dot and the line where there's no difference between these two conditions, that there's no meaningful difference between the two conditions. And clearly, there is some point at which we would start to say, ah, yes, there's a meaningful difference, but it's small, and there's a meaningful difference and it's big, meaningful difference and it's huge. And one of the central goals of statistics as a field is to help us to draw that inference, help us to decide how meaningful or how robust a difference is. So we might want to ask that in this case as well. Are we meaningfully or are we robustly different on average for the average person? Is the average person robustly different from the line where there's no difference between these two conditions?